So I'm gathering up all the parts I need for this buffer build. These are the 3/4 inch pillow blocks. I've got an old caster here that's got a 3/4 inch keyway in it. I was thinking maybe I could use that as a drive wheel. Not really sure if that makes sense or not, but we're gonna give it a shot. I got some big 3/4 inch locking washers. Got some bigger washers here, I figured, for the pads themselves, and some collets. Again, I'm not sure. I think these are collar. What do they call these here? Collars, not collets. Collar pins, I guess. Anyway, and then this is a piece of 12-inch 3/4. I'm not using this. I'm going to use a 24-inch piece, but I'll demonstrate how I think this should go down with the design. If this is on the grinder itself, this slides through here, gets locked in, right? And those are a few inches apart. And then this drive wheel slid over it, and then the pads on both sides, this side and this side. I think we have a pretty solid chance of making this work. This caster, being that it is kind of old, and I don't know how true it is. I don't know how much that matters really, but I think we've got a pretty decent concept here. So I'm going to go ahead and cut the piece out of the 3/4 inch all thread for my shaft, and then also load up the Crossfire Pro and cut the brace and the back plate for the pillow blocks, and then sort of kind of lay this all out. So I'm filling up the water table here. I don't know if you've seen some of my other videos, but I did create a water bin with a little fountain pump and a couple of valves there to push the water up into the table through the drain holes. And that's really working pretty nicely at the moment. So I'll leave that in place. It's working really great. The one caveat is I'm cutting this base plate out for with 0.375, which is 3/8 of an inch thick. I've never actually cut that thickness on the Pro, so I don't really fully know how that's going to go. I think I've got the program G-code set up correctly. I'm just going to give it a shot and see. I did soak this in vinegar. A lot of people are arguing with me on the forums about soaking your steel in vinegar and all of that, and my opinion is no, you don't have to do it. Do you get a better ground when you go to cut your steel? Yes. And then also when you go to weld it, you know, this etched steel like this, it just welds cleaner in my opinion. I've got a lot of experience doing this. It's not 100% necessary, and all these gents think that you know, I'm a moron for doing it, but it just helps. It helps an amateur welder make a better weld. And also I notice a lot less corrosion on the steel when I leave it like this in an etched state, or if I paint it, the paint sticks to it as well. So I just don't see a downside to it. If you've got the time, you can soak it. And these big pieces like this, I just went over to Home Depot and I got one of these dryer or washing machine bins. That's, you know, when you install a washing machine, you set it into one of these. And I just lay it in there and fill it with vinegar, let it soak for a couple days, pull it out. A little bit of a mess, but hey, it works for me. So here's the very simple sheet cam layout for the backer plate that holds the pillow block bearings, and then the brace, which is right here. I am gonna go ahead and cut these full amperage, 20 inches per minute. Like I said before, it's 3.375, which is 3/8 of an inch thick. And I've never done 3/8, so I don't know how the Pro is gonna handle it, but if it cuts anything like the 1/4 inch, slowing down the inches per minute will hopefully give this a nice clean cut. Also, I'm going to spray some anti-spatter on the nozzle just to make sure. This is the stuff I got from from Amazon, and it seems to help from keeping the spatter up off the machine shield. So yeah. Okay, we've got the G code pumped out of sheet cam, and now it's in fire control. We're gonna fire this beast up and see how it handles 3/8 of an inch thick plate steel. Okay, you can see the Crossfire Pro did a pretty great job of cutting this 3/8 inch thick plate steel. I am very impressed with that, and also I made these holes just a slightly bit oversized so they'll hold a 3/8 of an inch bolt, and it looks like the holes are all lining up as they should, which is a success in my mind. So I now have to look at the tooling arm, and I've got a old platen here that for my first belt grinder build that I'm gonna use, and take this off and see if I can clean it up and actually use this guy for the tooling arm. I don't use it much anymore, and I think it's time to decommission this platen, although I did make a cool soft platen for this using a Scotch-Brite belt and some leather, but it's getting pretty worn now from all the use. But yeah, let's see if we can use this. I'm not sure if it'll be the right length or not. I honestly don't have any frame of reference of how long the belt and the wheel and all of that, so the tooling arm is the one sort of wild card at the moment. Okay, so I took all the paint off of this tooling arm, and one of the things about using 2x2 and structural 2x2 and 1.5 by 1.5 is that it will nest together if you remove the weld seam out of the inside of the 2x2. But you do need to remove the mill scale. A lot of people like to argue with me about that until they actually try it, and then they're emailing me telling me, hey, it doesn't fit. Yeah, you need to remove the mill scale. Pretty easy to do with vinegar. So one of the things I do know about this process will need to be exactly at 90 degrees this way or at least parallel to the drive wheel itself will need to be parallel to the drive wheel back there. So it's really important that we mount that plate flat up against here and not cockeyed this way. So I think the easiest way to do that is with a digital level. So we were 0.05 on the wheel, or 0.09 here. I think that's good enough. All the hardware I need. Use 3/8 16 on this. Socket heads, washer on the front, and then a lock washer and a nut on the back side. These are 1.5 inches, I think, these socket heads. I think what makes most sense here is to level this whole thing before you lock it down, putting the shaft in and level it. So again, turning on the digital level, I'm gonna check just the wheel here. Check this. Zero that out. Set this here. Okay, so I've got it all leveled out. I've got it tacked in place and it feels pretty good. I don't want 3 feet of shaft. I don't think that's necessary. So I am going to shave this down to 24 inches or 2 feet. Just do that on the bandsaw over there, and then we can actually thread up some stuff and throw the wheel on it and just see if it spins without too much vibration. I think vibration is ultimately my biggest concern with this build, but hey, we will see. Okay, we got it all lined up for the most part. I feel like it's tracking pretty well at this point. I'm gonna turn this all the way down, hit run, and just spin it up a little bit and see what happens. All right, the belt seems a little loose. So I think I'm gonna try to pull this out just a little bit. A little more tension on the belt. Kind of hard to see in the video, but there is a little bit of vibration, and I don't know if it's coming from this old caster wheel or not. I've got another drive wheel that's supposed to be showing up today, so I might go ahead and replace this with the drive wheel and just see if there's any difference. It doesn't feel like there's a lot of play in these pillow block bearings, but it's possible too that this is warped. This I'm just spinning it here, and I can kind of see some just minor warpage in this this shaft, but for all in all, it actually ran pretty good for its first test run. It didn't explode or anything, and I didn't get a ton of vibration on the arm. It was almost all of it was right on these outer shaft pieces. Again, this could be smaller, and I'm thinking that that's probably what we're going to do is cut this down a little bit. But yeah, let's throw that different drive wheel on when it comes and see if there's any difference. So the package that I thought was the drive wheel was actually a new pulley for my one of my motors that I'll be doing a conversion for the Logan 400 lathe, the old one. So I'm gonna go ahead and just build this with what I got. Now I gotta be able to stop this, turn this. Need a big wrench. Definitely works. I don't think we need this much shaft, but I don't see how it can hurt to leave it there. And balance it out with another one on the other side. I think it might be bouncing a little bit because I put a lock washer on this side and it's off kilter, but I think I could definitely shave off, 3 inches, I don't know, maybe 4 total, and then center it again. I think that makes sense. All right, I shaved off about yay much. Didn't really measure. I think that will help. The buffing wheels that I bought, I wanted one to be more aggressive and then less aggressive so I can get out the scratches and stuff. So I'm gonna leave this one on here. I'm gonna leave this as a single. I did buy some of these big monster washer deals. I'm thinking I'm very happy with it. I think some minor modifications could be even take another inch out of this shaft, unless of course I want to add another wheel to this. I've seen some of the lapidary buffing systems, and they put in, you know, a spacer, although it gets a little difficult to use it. I think once you start moving, you know, you want a little room around the pad, which I feel like on this side I'm even running out of room because of the drive wheel. So what I probably could do is just shift the whole thing over, and hopefully it remains as balanced as it is. Overall, I'm really happy with it. I want to put some compound on this and just see if I can polish something and see what the motor does. But I can't imagine the motor bogging down too much. It's a 2 horsepower motor, and it's just it's a beast. So give that a shot and see. All right, so there you have it. A couple of things I definitely will be doing is adding Loctite to any of the set screws. Anything that's not supposed to move, essentially, will get Loctite. They just after one use, these start to vibrate loose, the set screws for the pillow block bearings, but it's not a huge deal. The locking nuts are working really great. They're the same locking nut actually that I use in the hardware kit for the Revolution 2x72. So it's just a 3/4 10 thread, and that works pretty great. Not a lot I'd change on this, guys. I can't believe on the first run that this thing actually is pretty solid and will work pretty well. One thing I might do is swap out this caster just for a standard drive wheel. I've got one on order from OBM, so we'll kind of check that out, see how it goes. But all in all, this is an additional reason to build the Revolution 2x72. I will find a way to either start selling the plates or just the DXF files for the plate so that you can make your own. This is, like I said, it's a very simple piece of equipment once you have the dimensions correct. I still actually need to finish my welds on this. Although I will say it's really quite solid. So not a lot I would change. Anyway, guys, if you got something out of today's video, make sure you hit that thumbs up button. And if you're not already subscribed, hit that subscribe button. And if you click that little bell, you'll get a notification every time I upload something to YouTube. There are many ways to support my channel. You can do that through Patreon, buy me a coffee, you can go on Amazon, and the link's down in the description. You can go shopping, I get a little piece of that commission when you do that, and that would be greatly appreciated. And again, guys, I hope to see you on the next video. My name is Brian House, and this has been Housework.